Okay, in this lecture we will discuss one of the example to design a band pass filter. So it is in a series of FIR filter examples. So it is question number 2. So the given question is design an FIR digital band pass filter of unity gain using triangular window whose upper and lower cutoff frequencies are 2 and 1 radians per sample respectively and length of the window is equal to 9. The solution will be first the given items m is equal to 9 in this case, which is odd. Second, omega C2 is upper, so 2 radians per sample. Omega C1 is 1 radian per sample is given. Now finding the type of filter to be used for designing of band pass. We have a FIR filter, so we have an option of type 1, type 2, type 3 and type 4. Out of this, these two are symmetric, these two are anti-symmetric. So type 1 odd m, type 2 even m, type 3 odd m, type 4 even m. So as m is equal to 9, this one is cancelled. We cannot use type 2. Similarly, we cannot use type 4 because the given m is odd sequence. Type 1 versatile, can be used with LPF, BPF and HPF. Type 3 not suitable for LPF and HPF. That's mean BPF can be designed using type 1 and type 3. For the ease, we will use type 1 filter as it is most versatile filter. Then we know for type 1 filter Hn will be equal to H m minus 1 minus n and T will be equal to m minus 1 by 2, that is equal to 4. Then we will first evaluate ideal filter response. That is Hd omega equals to exponential minus j t omega c1 mod omega mod omega C2 mod and 0 elsewhere. Then calculating HDN is HDN equals to 1 by 2 pi minus pi to pi exponential minus j t omega exponential j omega n d omega, and it is equal to 1 by 2 pi minus of omega c2 to minus of omega c1 exponential j omega n minus t plus 1 by 2 pi omega c1 omega c2 exponential j omega n minus t. Integrating these equations will give 1 by 2 pi j n minus t. There is d omega here and d omega here. Then it will be exponential j omega n minus t minus omega c2 minus of omega c1 plus 1 by 2 pi j n minus t exponential j omega n minus t omega c1 omega c2. Substituting the limits will give 1 by 2 pi j n minus t exponential j omega minus j omega c1 n minus t minus exponential minus j omega c2 n minus t plus exponential j omega c2 n minus t minus exponential j omega c1 n minus t. Rearranging the terms will give 1 by pi n minus t 1 by 2j exponential j omega c2 n minus t minus sign exponential minus j omega c2 n minus t. Then taking minus common exponential j omega c1 n minus t minus exponential minus j omega c1 n minus t. This will give 1 by pi n minus t, taking 1 by 2j inside and solving these equations as Euler's identity, will get sine omega c2 n minus t minus sine omega c1 n minus t. Now this is the response we have obtained for HDN. Now we know HDN follows the linear phase response. As per the condition specified, that is starting the values from HD0 that is D0 will be equal to HD8, M minus 1 minus N will be equal to HM. For HD0 it will be HD8, HD1 will be equal to HD7, HD2 will be equal to HD6, HD3 will be equal to HD5 and then HD4. Now calculating HD0 is equal to 1 by pi n minus t, where t is equal to m minus 1 by 2, that is equal to 4. So n minus 4 sine omega c2. Omega c2 is equal to 2 radians per sample, that is 2 n minus 4. Then minus sine omega c1. Omega c1 is 1 radian per sample. 1 n minus 4. Now putting the value for n equals to 0. Will give 1 by minus 4 pi sine minus 8 minus sine minus 4. Taking all sign common, it will be 1 by 4 pi sine 8 minus sine 4, which is equal to 0.138. So we have find out HD0. Next we'll find out for HD1, that is also equal to HD7. So that will be 1 by pi and minus 4 sine 2 n minus 4 minus sine 1 n minus 4. In this case n will be equal to 1, this is 1, here this goes to 0. Then this equation can be solved as minus 1 by 3 pi sine minus 6 minus sine minus 3 will be equal to 1 by 3 pi sine 6 minus sine 3, which will be equal to, if we solve, the result is minus 0.0446. Now for HD2, this n will be 2, and this will also be equal to 2. Then we can write this equation as minus 1 by 2 pi sine minus 4 minus sine minus 2. Then it can be written as 1 by 2 pi sine 4 minus sine 2, which is equal to minus 0.2651. Now for HT3, this n will be equal to 3. This will also go to 3 and this will also go to 3. Then the equation will be equal to minus 1 by pi sine minus 2 minus sine minus 1, which is equal to 1 by pi sine 2 minus sine 1. Solving this will give 0.02158. Now we have to find out the center value, that is HD4 equals to 1 by pi n minus 4 sine 2 n minus 4 minus sine 1 n minus 4 at n equals to 4. Now if you substitute n equals to 4, this equation will go to 0 by 0's form. To remove this problem, we will use L'Hospital rule, which is del by del n sine 2 n minus 4 minus sine 1 n minus 4 over del by del n pi n minus 4 for n equals to 4. This relation will give cosine 2 cosine 2 n minus 4 minus cosine 1 n minus 4 over pi for n equals to, substituting n equals to 4 will give 2 minus 1 by pi equals to 1 by pi. So HDN is equal to, so the ideal filter response HDN, which is actually from minus infinity to infinity, but we have find out only the 9 terms, that is 0.138 minus 0.00446 minus 0.2651 0.02158 comma 1 by pi 0.02158 minus 0.2651 minus 0.00446 and 0.138. 1 by pi can be also written as 0.318. Okay, so we will substitute that value so that it will match with other values, that is 0.318. Now we know to find out the filter response, we have to truncate this particular sequence for a causal triangular window can be represented as window Tn equals to 1 minus 2 mod n minus m minus 1 by 2 over m minus 1 from 0 to m minus 1 and 0 elsewhere. Now we know m is equal to 9. Then Wtn will be equal to 1 minus 2 mod n minus 4 over 8 0 n up to 8 and 0 elsewhere. So we can find out all the values of Wtn. First, Wt0, that will be equal to 1 minus 2 minus 4 by 8 will be equal to 1 minus 8 by 8 equals to 0. Then Wt1 will be equal to 1 minus 2 1 minus 4 by 8 equals to 1 minus 6 by 8 will give 2 by 8, which can be written as 0.25. Then Wt2 will be equal to 1 minus 2 2 minus 4 by 8, which can be written as 1 minus 4 by 8 and equals to 1 by 2, that is equal to 0.5. Next is Wt3, which is equal to 1 minus 2 3 minus 4 by 8 equal to 1 minus 2 by 8, and this is equal to 6 by 8, which is equal to 0.75. Then Wt4 will be equal to 1 minus 2 4 minus 4 by 8, this will go to 0, so it is 1. Then Wt5, which will be equal to 1 minus 2 5 minus 4 by 8, please note this term, so it will give 1 minus 2 by 8, which is same as of this, because it has to be a triangular sequence, so that's mean Wt5 is equal to Wt3, Wt6 is equal to Wt2 and Wt7 is equal to Wt1, and at last Wt8 is equal to Wt0. Then we can write Wt and window values we have obtained is 0, 0.25, 0.5, 0.75, 1, 0.75, 0.5, 0.25 and at last 0. Now by definition we have to truncate the ideal sequence, that is HDN, by multiplying with the window sequence will give the impulse response, that is HN. Then HN will be equal to is 0 minus 0.001115 minus 0.13255, 0.016185, 0.3183, 0.016185 minus 0.13255 minus 0.00115 and then 0. Now we have obtained the impulse response of the filter in time domain. Now we want to find out its frequency response, that is h omega, and that will be equal to summation n equals to minus infinity to infinity Hn exponential minus j omega n. Now we know this Hn is defined from n equals to 0, m minus 1, Hn exponential minus j omega n. Now we will open this complete equation and we'll get equation in terms of Hn and exponential minus j omega n, which we have already evaluated in the previous example. So we'll directly use that particular equation here, which is 2 exponential minus j omega m minus 1 by 2 h0 cos omega m minus 1 by 2 plus h1 cos omega m minus 3 by 2 h2 cos omega m minus 5 by 2 plus f2 1 by 2 hm minus 1 by 2. Now for this case, m is equal to 9, then is equal to 2 exponential minus j omega 4 h0 cos 4 omega plus h1 cos 3 omega plus h2 cos 2 omega plus h3 cos omega and plus 1 by 2 h4. Now we already have these values of h0, h1, h2, h3 and h4 with us. Then h omega will be equal to 2 exponential minus 4j omega h0 is equal to 0 for triangular window, then this entire terms goes to 0. h1 is equal to minus 0.00115, then h2 is minus 0.13255, h3 is 0.016185, then h4 is 0.3183. Then writing this equation will give minus 0.005 cos 3 omega minus 0.13255 cos 2 omega plus 0.016185 cos omega and plus 0.15915 dividing 0.3183 by 2 will give this. So this is h omega impulse response in frequency domain we have calculated for a filter by implementing triangular window. That's all for today. We'll discuss few more examples in next classes. Thank you.